Hello, my dear 9 students. This video explains you about various separation techniques which we were discussing in the previous video. You have been waiting for the video from so long. Sorry for the delay. So, in the previous video, we had discussed about three separation technique. One we had discussed, it was evaporation to separate volatile substance from non-volatile substance. Then second one we had discussed about centrifugation, in which we had discussed that lighter particles are forcibly made to settle down when spun at greater speed. Then third one we had discussed in the previous video was about separating funnel, which is used to separate two immiscible liquids, which separate out as two different layers based on the densities. Now, we'll move ahead with other separating techniques. That is, next one that we are going to discuss is to separate ammonium chloride from salt. Ammonium chloride is NH4Cl. This is the formula of ammonium chloride. So this ammonium chloride from salt, how can we separate it? If you remember in the video regarding first chapter, that is matter in our surrounding, we had discussed about one concept, that is sublimation. Do you remember? There I said few sublimable substances. Among that sublimable substances, NH4Cl, that is ammonium chloride, is also one. Other than ammonium chloride, we have even discussed camphor is sublimable, naphthalene balls are sublimable. So we had discussed about this in the first chapter under the concept sublimation. Now, coming to this sublimation is a process of converting solid directly into gas without reaching liquid state, isn't it? So, this sublimation happens for few substances. The substances which can sublime are called as sublimable substances. So, ammonium chloride directly changes from solid to gas on heating without reaching liquid state. So, it can undergo sublimation. Whereas salt, common salt, whichever we use in our kitchen, that do not undergo sublimation. When we heat it, it will actually it require very high temperature to get melted, but it will not sublime as ammonium chloride does because it is non-sublimable substance. So to separate sublimable volatile substance from non-sublimable impurities, we'll go for this technique of sublimation. Example, when we want to separate naphthalene, anthracene or camphor from non-sublimable substance like salt, we'll go for this technique of sublimation. Technique I have already explained. We need to take a tripod stand and above the tripod stand keep a china dish in which the mixture has to be put, and above which we should keep a funnel inverted. Mouth of the funnel should be plugged with cotton plug, and we should start heating with the help of burner. When you heat it, you will see that ammonium chloride start to convert to vapor, and those vapors which touches the neck of the inverted funnel start cooling down and they condense there. So those vapors which have converted from solid state due to the heat will again solidify by cooling. So by this, salt remains in the china dish, whereas camphor vapors or naphthalene vapors or ammonium chloride vapors will segregate at the neck of the funnel. By scraping it out from the neck of the funnel, we can separate out salt from sublimable substances. So this sublimation is also a technique of separating substances, separating components of a mixture. Shall we go ahead? Here I have shown you camphor. Camphor is also one of the substances which can undergo sublimation. Moving ahead. There's one more separation technique, that we use in laboratories in day-to-day life, that is separation of dyes in the ink. We have discussed how to separate ink, dye and ink. ಅರ್ಥ ಆಯ್ತಾ? ಇಂಕ್ ಅಲ್ಲಿ ಡೈ ಇರುತ್ತೆ, ಅದನ್ನ ಹೇಗೆ ಸಪರೇಟ್ ಮಾಡೋದು ಅಂತ ಫಸ್ಟ್ ಸಪರೇಷನ್ ಟೆಕ್ನಿಕಲಿ ಕಲ್ತಿದೀವಿ ಆಸ್ ಎವಾಪರೇಷನ್. ವೆರ್ ಎಸ್ ಹಿಯರ್ ಇಂಕ್ ಅಲ್ಲಿ ಇರೋ ಡೈಸ್ ಕ್ಯಾನ್ ಬಿ, ಇಂಕ್ ಕ್ಯಾನ್ ಹ್ಯಾವ್ ಡಿಫರೆಂಟ್ colored dyes. Ink is actually mixture of dyes. Okay, when we heat it, water content or solvent will evaporate. Okay, when we heat it, solvent or liquid content will evaporate. Haudalva? Then dye remains. That dye is again contain red dye, blue dye, or various colors will be present in that particular dye. So if we want to separate those dyes present in the ink, we'll go for a technique called as chromatography. It's called as chromatography. Okay, what is this chromatography? Let us try to understand. It's a technique of separation of components of mixture that dissolves in same solvent. ನೋಡಿ ಮಕ್ಕಳೇ, ಪ್ರತಿಯೊಂದು ಸಪರೇಷನ್ ಟೆಕ್ನಿಕ್ಕಿಗೂ ಅದ್ರದ್ದೇ ಆದ ಪ್ರಿನ್ಸಿಪಲ್ ಇದೆ. ಯಾವುದೇ ಮಿಕ್ಸರ್ ಅನ್ನ ಯಾವುದೇ ಸಪರೇಷನ್ ಟೆಕ್ನಿಕ್ ಇಂದ ಸಪರೇಟ್ ಮಾಡೋದಕ್ಕೆ ಬರಲ್ಲ. ಪ್ರತಿಯೊಂದು ಮಿಕ್ಸರ್ಗೂ ಅದರದ್ದೇ ಆದ ಸಪರೇಷನ್ ಟೆಕ್ನಿಕ್ ಅನ್ನ ಫಾಲೋ ಮಾಡಬೇಕು, ಅಥವಾ ಅದರದ್ದೇ ಆದ ಸಪರೇಷನ್ ಟೆಕ್ನಿಕ್ ಬೇಸ್ಡ್ ಆನ್ ಸಮ್ ಪ್ರಿನ್ಸಿಪಲ್ ಆಗಿರತ್ತೆ. ಕ್ರೊಮ್ಯಾಟೋಗ್ರಫಿ ಪ್ರಿನ್ಸಿಪಲ್ ಏನು ಅಂತ ಅಂದ್ರೆ, ಇದನ್ನ ನಾವು ಯಾವಾಗ ಯೂಸ್ ಮಾಡಬಹುದು? ವೆನ್ ದ components of a mixture is able to dissolve in the same solvent. For example, ಉಪ್ಪು ಸಕ್ಕರೆ ಸೇಮ್ ಸಾಲ್ವೆಂಟ್ ಅಲ್ಲಿ ಕರಗತ್ತೆ, ಆ ತರ. ಹಾಗಂತ ಉಪ್ಪು ಸಕ್ಕರೆನ ಕ್ರೊಮ್ಯಾಟೋಗ್ರಫಿಯಿಂದ ಸೆಪರೇಟ್ ಮಾಡೋದಕ್ಕೆ ಆಗಲ್ಲ. Okay, so this chromatography is to separate the components of a mixture that dissolves in same solvent. ಇನಿಷಿಯಲಿ ಫಸ್ಟ್ ಇದನ್ನ ಏನಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ರು ಅಂದ್ರೆ, ಕಲರ್ಸ್ ಅನ್ನ ಸಪರೇಟ್ ಮಾಡೋದಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ರು. ಅದಕ್ಕೆ ಹೆಸರು ಕ್ರೊಮ್ಯಾಟೋಗ್ರಫಿ ಅಂತ ಕೊಟ್ರು. ಕ್ರೋಮಾ ಮೀನ್ಸ್ ಕಲರ್. So the component that dissolves more in the solvent moves faster, and the less will be moving slower, so it gets separated. ಹೇಗೆ ಅಂತ ನಾನು ಕ್ರೊಮ್ಯಾಟೋಗ್ರಫಿ ಇದು ವಿಡಿಯೋ ತೋರಿಸ್ತೇನೆ ನಿಮ್ಗೆ. Okay, with the help of Amrita Vishwavidyapeetham made online videos, with the help of that virtual lab, I'll show you. So here chroma means color. ಸೊ ಕಲರ್ ನ ಸೆಪರೇಟ್ ಮಾಡೋದಕ್ಕೆ ಫಸ್ಟ್ ಈ ಟೆಕ್ನಿಕ್ ಅನ್ನ ಯೂಸ್ ಮಾಡಿದ್ದಕ್ಕೆ ಕ್ರೊಮ್ಯಾಟೋಗ್ರಫಿ ಅಂತ ಕರೆದ್ರು. ಹಾಗಂತ ಕಲರ್ ಸೆಪರೇಟ್ ಮಾಡೋದಕ್ಕೆ ಮಾತ್ರ ಯೂಸ್ ಮಾಡ್ತಾರಾ? No, nowadays we use this technique for various other purposes also. So let us watch a video regarding chromatography and come back for the discussion. Thanking Amrita Vishwavidyapeetham for these beautiful videos to understand laboratory techniques virtually.
Chromatography. Chromatography is a separation technique used to separate the different components in a liquid mixture. There are different types of chromatographic techniques such as column chromatography, TLC, paper chromatography, and gas chromatography. Paper chromatography is one of the important chromatographic methods. Paper chromatography uses paper as the stationary phase and the liquid solvent as the mobile phase. In paper chromatography, a spot of the mixture is put on the paper and the paper is carefully dipped into a solvent. The solvent rises up the paper due to capillary
ಇದರಲ್ಲಿ ಮಕ್ಕಳೇ ಪೇಪರ್ ಅಂತ ಹೇಳ್ತಾ ಇದಾರಲ್ಲ ಅವರು, ಅದಕ್ಕೆ ನಾರ್ಮಲ್ ಪೇಪರ್ ತಗೊಂಡ್ರೆ ಸೆಪರೇಷನ್ ಅಷ್ಟು ತುಂಬಾ ಕ್ಲಿಯರ್ ಆಗಿ ಕಾಣಿಸಲ್ಲ. ವಾಟ್ಮೆನ್ ಪೇಪರ್ ಅಂತ ಇರುತ್ತೆ, ಆ ಪೇಪರ್ ಅನ್ನ ಕ್ರೊಮ್ಯಾಟೋಗ್ರಫಿ ಪೇಪರ್ ಅಂತಾನು ಹೇಳ್ತಾರೆ. ಆ ಪೇಪರ್ ಅಲ್ಲಿ ಕ್ರೊಮ್ಯಾಟೋಗ್ರಫಿ ತುಂಬಾ ನೀಟಾಗಿ ಕ್ಲಿಯರ್ ಆಗಿ ಕಾಣಿಸುತ್ತೆ.
Reaction and the components of the mixture rise up at different rates and
ಇಲ್ಲಿ ನೋಡಿ ಎಷ್ಟು ನೀಟಾಗಿ ಆರೆಂಜು ಮತ್ತೆ ರೆಡ್ ಮತ್ತೆ ಬ್ಲೂ ಸೆಪರೇಟ್ ಆಗಿರೋದು ನಿಮ್ಗೆ ಕಾಣಿಸುತ್ತೆ.
thus get separated from one another. Materials required: chromatographic chamber, Whatman filter paper strip, capillary tubes, measuring cylinder, thread, isopropyl alcohol, mixture of red and blue inks, distilled water, glass rod, scale, and pencil. Procedure: take a Whatman filter paper strip and draw a line with a pencil about 2 centimeters from one end. Put a pencil mark at the center of the line. Now, take a capillary tube and dip it into the beaker containing a mixture of red and blue inks. Using the
ಇದು ಕ್ಯಾಪಿಲರಿ ಟ್ಯೂಬ್ ನ ಯಾಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ ಡ್ರಾಪ್ ಬೈ ಡ್ರಾಪ್ ಲಿಟಲ್ ಅಮೌಂಟ್ ನ ಹಾಕೋದಕ್ಕೆ ಅದು ಹೆಲ್ಪ್ಫುಲ್. ಅದನ್ನ ನಾವು ಲಿಕ್ವಿಡ್ ಅಲ್ಲಿ ಇಟ್ಟಾಗ ಅದು ಕ್ಯಾಪಿಲರಿ ಆಕ್ಷನ್ ಇಂದ ಲಿಕ್ವಿಡ್ ಆ ಟ್ಯೂಬ್ ಒಳಗಡೆ ಬರುತ್ತೆ. ಅದನ್ನ ತಗೊಂಡೋಗಿ ವಾಟ್ಮ್ಯಾನ್ ಪೇಪರ್ ಅಲ್ಲಿ ಮಾರ್ಕ್ ಮಾಡಿರೋ ಜಾಗದಲ್ಲಿ ಡ್ರಾಪ್ ಮಾಡಿದ್ರೆ, ಪ್ರೆಷರ್ ನ ಮೇಲೆ ಹಿಡ್ಕೊಂಡಿರೋದನ್ನ ಬಿಟ್ರೆ ಅದು ಕೆಳಗಡೆ ಡ್ರಾಪ್ ಆಗುತ್ತೆ.
capillary tube, put a drop of the mixture of red and blue inks at the central point of the line. Allow it to dry in open air. Again, take the mixture of red and blue inks using the capillary tube. Put another drop on the same spot and dry it again so that the spot is rich in mixture. Now, take a piece of thread and tie the filter paper with it and suspend the filter paper vertically in the chromatographic chamber containing the solvent, which is a mixture of 80% isopropyl alcohol and 20% water. Make sure that pencil line remains about 1 centimeter above the solvent level. Keep the chamber undisturbed for some time. Notice the rise in salt.
ನೋಡಿ ಅವ್ರು ಹಾಗೆ ಇಟ್ಟಾಗ ಇದರಲ್ಲಿ ನೋಡಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಹಾ ಸ್ವಲ್ಪ ಹೊತ್ತು ಹಾಗೆ ಅನ್ಡಿಸ್ಟರ್ಬ್ ಆಗಿ ಇಟ್ಟಾಗ ಏನಾಗ್ತಾ ಇದೆ ಅಂತಂದ್ರೆ, ಯು ಕ್ಯಾನ್ ಸಿ ದಟ್ ಬ್ಲೂ ಇಂಕು ಫಸ್ಟ್ ಟ್ರಾವೆಲ್ ಮಾಡೋದಕ್ಕೆ ಶುರು ಮಾಡಿದೆ ಇಲ್ಲಿ. ಏನಕ್ಕೆ ಅಂದ್ರೆ ಬ್ಲೂ ಇಂಕು ಈ ಸಾಲ್ವೆಂಟ್ ಅಲ್ಲಿ, ಎರಡು ಇಂಕು ಸಾಲ್ವೆಂಟ್ ಅಲ್ಲಿ ಕರಗತ್ತೆ, ಆದ್ರೆ ಬ್ಲೂ ಇಂಕು ಫಾಸ್ಟ್ ಆಗಿ ಕರಗಿದೆ, ಅದಕ್ಕೆ ಅದು ಫಾಸ್ಟ್ ಆಗಿ ಮೇಲೆ ಟ್ರಾವೆಲ್ ಮಾಡಿ.
Notice the rise in solvent along with the mixture of red and blue inks. When the solvent has risen, you will notice two different spots of blue and red colors on the filter paper. Take the filter paper out of the chamber and mark the distance that the solvent has risen on the paper with a pencil. This is called the solvent front. Dry the paper and put pencil marks in the center of the blue and red spots. Measure the distance of the solvent front from the original line and the distance of the two spots from the original line. Calculate the RF values of the blue and red inks by using the formula. RF is equal to distance traveled by the solute from the original line divided by the distance traveled by the solvent from the original line.
ನಿಮಗೆ ಇದೇನು ಡಿಸ್ಟೆನ್ಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದಿಲ್ಲ, ಬಟ್ ಇದರಲ್ಲಿ ನೀವು ಕ್ಲಿಯರ್ ಆಗಿ ನೋಡಿದ್ರಿ ದಟ್ ಬ್ಲೂ ಇಂಕು ತುಂಬಾ ಟಾಪ್ ಅಲ್ಲಿ ಹೋಗಿದೆ, ರೆಡ್ ಇಂಕು ಕೆಳಗಡೆ ಇದೆ. ಏನಕ್ಕಂದ್ರೆ ಬ್ಲೂ ಹ್ಯಾಸ್ ಡಿಸಾಲ್ವ್ ಮೋರ್ ಇನ್ ದ ಸಾಲ್ವೆಂಟ್ ದ್ಯಾನ್ ದ ರೆಡ್. ಗೊತ್ತಾಯ್ತಲ್ಲ ಮಕ್ಕಳೇ ಕ್ರೊಮ್ಯಾಟೋಗ್ರಫಿ ಹೇಗೆ ಅಂತ? ಸೊ ದಟ್ಸ್ ಆಲ್. ಸೊ ಇದೇ ತರ ಕ್ರೊಮ್ಯಾಟೋಗ್ರಫಿನ ವಿ ಕ್ಯಾನ್ ಆಲ್ಸೋ ಡೂ ಫಾರ್ ಡೂ ವಿತ್ ದ ಹೆಲ್ಪ್ ಆಫ್ ಚಾಕ್ ಪೀಸ್. ಚಾಕ್ ಪೀಸ್ ಅಲ್ಲೂ ನಾವು ಮಾಡಬಹುದು. ಚಾಕ್ ಪೀಸ್ ತಗೊಂಡು ಚಾಕ್ ಪೀಸ್ ಅಲ್ಲಿ ಕೆಳಗಡೆ ಬಾಟಮ್ ಅಲ್ಲಿ ಒಂದ್ ಸ್ವಲ್ಪ ಆಲ್ಮೋಸ್ಟ್ 1 ಸೆಂಟಿಮೀಟರ್ ಬಿಟ್ಬಿಟ್ಟು ಇಫ್ ಯು ಡ್ರಾ ಯೂಸಿಂಗ್ ದ ಸ್ಕೆಚಸ್ ಆರ್ ಇವನ್ ಯೂಸಿಂಗ್ ಮಾರ್ಕರ್ಸ್, ಬೇರೆ ಬೇರೆ ಕಲರ್ ಮಾರ್ಕರ್ ಇಂದ ಡ್ರಾ ಮಾಡಿದ್ರೆ ಕಲರ್ನ ಹಚ್ಚಿದ್ರೆ ಚಾಕ್ ಪೀಸ್ ಮೇಲೆ, ವೈಟ್ ಚಾಕ್ ಪೀಸ್ ಮೇಲೆ ಹಚ್ಚಿ ಅದನ್ನ ಒಂದು ವಾಚ್ ಗ್ಲಾಸ್ ಅಲ್ಲಿ ನೀರಲ್ಲಿ ಡಿಪ್ ಮಾಡಿ ಇಟ್ಟಾಗ ಕಲರ್ ಮೇಲೆ ರೈಸ್ ಆಗೋದು ಕ್ಲಿಯರ್ ಆಗಿ ಕಾಣಿಸುತ್ತೆ. ಅದಕ್ಕೆ ಚಾಕ್ ಕ್ರೊಮ್ಯಾಟೋಗ್ರಫಿ ಅಂತಾನು ಹೇಳ್ತೀವಿ. ಸೊ ದಿಸ್ ಕ್ರೊಮ್ಯಾಟೋಗ್ರಫಿ ಈಸ್ ವೆರಿ ಬ್ಯೂಟಿಫುಲ್ ಟೆಕ್ನಿಕ್. ನೋಡೋದಕ್ಕೂ ಕೂಡ ತುಂಬಾ ಚೆನ್ನಾಗಿ ಅನ್ಸುತ್ತೆ. ಬ್ಯೂಟಿಫುಲ್ ಟೆಕ್ನಿಕ್ ಅಂಡ್ ಯೂಸ್ ಟು ಸೆಪರೇಟ್ ಕಲರ್ಸ್ ಇನಿಷಿಯಲಿ, ಬಟ್ ನೌ ಇಟ್ ಈಸ್ ಫಾರ್ ಅದರ್ ಪರ್ಪಸಸ್ ಆಲ್ಸೋ. ಹಾಗಾದ್ರೆ ಏನದು ಅದರ್ ಪರ್ಪಸಸ್ ನೋಡೋಣ. What's the application of chromatography? Chromatography is widely used to separate color in a dye, and even if I'll take a leaf, okay, leaf is green in color, but that green color leaf is having not just chlorophyll. Along with chlorophyll, it's also having other pigments like xanthophyll, right? Anthocyanin, other pigments might also be there. If we want to separate those pigments from natural colors, ಯಾವ pigments ಇದೆ ಗೊತ್ತು ಮಾಡ್ಕೋಬೇಕಲ್ವಾ? ಕ್ಲೋರೋಫಿಲ್ ಅಲ್ಲೂ ಕ್ಲೋರೋಫಿಲ್ ಎ, ಕ್ಲೋರೋಫಿಲ್ ಬಿ ಅಂತ ಇರುತ್ತೆ. ಕ್ಯಾರೋಟಿನಾಯ್ಡ್ ಆರೆಂಜ್ ಕಲರ್ ಪಿಗ್ಮೆಂಟ್ ಇರುತ್ತೆ. ಸೊ ಅದೆಲ್ಲ ಪಿಗ್ಮೆಂಟ್ಸ್ ಅನ್ನ ಸಪರೇಟ್ ಔಟ್ ಮಾಡೋದಕ್ಕೆ ವಿ ಯೂಸ್ ದ ಸೇಮ್ ಟೆಕ್ನಿಕ್. ದೆನ್ ಡ್ರಗ್ಸ್ ಫ್ರಮ್ ದ ಬ್ಲಡ್ ಅಲ್ಲೂ ದೇರ್ ಮೇ ಬಿ ಮಿಕ್ಸ್ಚರ್ ಆಫ್ ವೇರಿಯಸ್ ಡ್ರಗ್ಸ್. ವೆನ್ ಡ್ಯೂ ಟು ವೇರಿಯಸ್ ರೀಸನ್ಸ್, ನಾವು ತಗೊಂಡಿರೋ ಟ್ಯಾಬ್ಲೆಟ್ ಇಂದ ಆಗಿರಬಹುದು ಅಥವಾ ಬಾಡಿಲಿ ಪ್ರೊಡ್ಯೂಸ್ ಆಗಿರೋ ಅಂತ ಅನ್ವಾಂಟೆಡ್ ಮೆಟೀರಿಯಲ್ಸ್ ಇಂದ ಆಗಿರಬಹುದು. ಸೊ ದೇರ್ ಮೇ ಬಿ ಡ್ರಗ್ಸ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ದ ಬ್ಲಡ್. ಅದನ್ನ ಸೆಪರೇಟ್ ಔಟ್ ಮಾಡೋದಕ್ಕೂ ಕೂಡ ವಿ ಯೂಸ್ ದಿಸ್ ಟೆಕ್ನಿಕ್ ಆಫ್ ಕ್ರೊಮ್ಯಾಟೋಗ್ರಫಿ. ಸೊ ದೀಸ್ ಆರ್ ದ ಅಪ್ಲಿಕೇಶನ್ ಆಫ್ ಕ್ರೊಮ್ಯಾಟೋಗ್ರಫಿ. So let us now understand separation of mixture of two miscible liquids. Dear children, we had discussed about immiscible liquids in the previous video. Immiscible liquids are those which will separate out as two different layers, whereas miscible liquids, they mix homogeneously with each other without forming any boundaries. No boundaries are formed in case of miscible liquids. For example, alcohol and water. Alcohol and water is an example for miscible liquids. Even acetone and water, or it can be acetone and water is also example for miscible liquids. So ಈ miscible liquids ಒಂದಕ್ಕೊಂದು ಮಿಕ್ಸ್ ಆಗಿರುತ್ತೆ. ಅದು ಮಿಕ್ಸ್ ಆಗಿದೆ ಅಂತಾನು ನಮ್ಗೆ ಸೆಪರೇಟ್ ಕಾಣಿಸಲ್ಲ. ಕಾಣಿಸಿದ್ರೆ ಅದು ಇಮ್ಮಿಸಿಬಲ್ ಲಿಕ್ವಿಡ್ ಆಗ್ಬಿಡತ್ತೆ. ಇದು ಕ್ಲಿಯರ್ ಆಗಿ ಹೋಮೋಜಿನಸ್ ಆಗಿ ಮಿಕ್ಸ್ ಆಗಿರುತ್ತೆ. ಅದನ್ನ ಹೇಗೆ ಸೆಪರೇಟ್ ಔಟ್ ಮಾಡೋದು? ದೇರ್ ಇಸ್ ಎ ಟೆಕ್ನಿಕ್ ಟು ಸೆಪರೇಟ್ miscible liquids that's called as distillation. It's called as distillation. This distillation ಅಂತಂದ್ರೆ ಏನು? Actually distillation means process of heating the liquid. ಏನ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ we'll heat the liquids, heat the mixture. Mixture ಅಂದ್ರೆ it's a mixture of liquid. Heat the mixture of liquid. When we heat any liquid, it start to convert to vapor ಅಲ್ವಾ? Convert to vapor. ಆ vapor ಅನ್ನ ಏನ್ ಮಾಡ್ತೀವಿ? Cool down so that it condenses again. Condenses to liquid again. This process is called as distillation. Distillation is nothing but converting liquid into gas, gas back into liquid. Okay, so that's called as distillation. That means vaporization followed by condensation is distillation. ಹೇಗೆ ಮಾಡ್ತೀವಿ ಇದನ್ನ? ಎಲ್ಲದಕ್ಕೂ ಒಂದೇ ತರ ಡಿಸ್ಟಿಲೇಷನ್ ಟೆಕ್ನಿಕ್ ಇರತ್ತಾ? Let us understand. So coming to distillation, it's used to separate two miscible liquids that boil without decomposition and have sufficient difference in the boiling point. ಎರಡು ಮಿಕ್ಸರ್ ಮಿಕ್ಸ್ ಆಗಿರುತ್ತೆ, ಎರಡು ಲಿಕ್ವಿಡ್ ಮಿಕ್ಸ್ ಆಗಿರುತ್ತೆ. ಅದನ್ನ ನಾನು ಹೀಟ್ ಮಾಡಿದಾಗ ಆ ಮಿಕ್ಸರ್ ಅಲ್ಲಿ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ವಾಟರು ಆಲ್ಕೋಹಾಲ್ ಇದ್ದಾಗ ಆಲ್ಕೋಹಾಲ್ ಏನಾದ್ರು ಬ್ರೇಕ್ ಡೌನ್ ಆಗಿ ಹೊಸ ಎರಡು ಕಾಂಪೋನೆಂಟ್ಸ್ ಆದ್ರೆ ಡಿಕಂಪೋಸ್ ಆಗ್ಬಿಟ್ರೆ ಅವಾಗ ನಾನು ಡಿಸ್ಟಿಲೇಷನ್ ಯೂಸ್ ಮಾಡೋದಕ್ಕೆ ಬರಲ್ಲ. ಯಾವುದು ಹೀಟ್ ಮಾಡಿದಾಗ ಡಿಕಂಪೋಸ್ ಆಗಲ್ವೋ, ಬ್ರೇಕ್ ಡೌನ್ ಆಗಲ್ವೋ, ಅದನ್ನ ನಾನು ಡಿಸ್ಟಿಲೇಷನ್ ಮೂಲಕ ಸೆಪರೇಟ್ ಔಟ್ ಮಾಡಬಹುದು. ಅಂಡ್ ಇನ್ನೊಂದನ್ನ ನೆನ್ಪಿಟ್ಕೋಬೇಕು, ಡಿಸ್ಟಿಲೇಷನ್ ನಾನು ಫಾಲೋ ಮಾಡುವಾಗ ಎರಡರದ್ದು ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಒಂದೇ ಆಗಿರಬಾರ್ದು. ಇಫ್ ಬೋತ್ ಆರ್ ಹ್ಯಾವಿಂಗ್ ಸೇಮ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಆರ್ ನಿಯರ್ ಬೈ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್, ಒಂದು 5 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಡಿಫ್ರೆನ್ಸ್, ಒಂದು 100 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಇನ್ನೊಂದು 105 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಆ ತರ ಇದ್ರೆ, both will start getting converted to vapor together and both will start cooling down together. It won't get separated at all. Mixture remain as mixture. So if we want to follow this distillation technique, the difference between the boiling point must be present. There should be sufficient difference between the boiling point. Moving ahead, there are two types of distillation. Based on the difference in the boiling point, two types of distillation irutte. One, simple distillation. In case of this simple distillation, difference in the boiling point should be more than 25 Kelvin. 25 Kelvin ginta ಜಾಸ್ತಿ difference ಇದ್ದಾಗ we'll go for simple distillation. But when the difference between the boiling point is less than 25 Kelvin, then we'll go for fractional distillation. For example, gases from air, petroleum product na extract ಮಾಡೋದಿರಬಹುದು. Petroleum product means it can be petrol, diesel, kerosene. ಇದನ್ನ ಫ್ರಮ್ ಪೆಟ್ರೋಲಿಯಂ ಇಂದ ಇದನ್ನ ಎಕ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡುವಾಗ ವಿ ಯೂಸ್ ಫ್ರಾಕ್ಷನಲ್ ಡಿಸ್ಟಿಲೇಷನ್. ವೆನ್ ಡು ವಿ ಯೂಸ್ ಫ್ರಾಕ್ಷನಲ್ ಡಿಸ್ಟಿಲೇಷನ್? ವೆನ್ ಡಿಫರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಈಸ್ ಲೆಸ್ ದ್ಯಾನ್ 25 ಕೆಲ್ವಿನ್. ಆವಾಗ ನಾವು ಫ್ರಾಕ್ಷನಲ್ ಡಿಸ್ಟಿಲೇಷನ್ ಅನ್ನು ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಗೊತ್ತಾಯ್ತಾ ಮಕ್ಕಳೇ? ಸೊ ಡಿಸ್ಟಿಲೇಷನ್ ಕ್ಯಾನ್ ಬಿ ಆಫ್ two types: simple distillation and fractional distillation. So we need to understand how this distillation happens. In fractional distillation, only difference is fractionating column will be fixed above between the distillation flask and the condenser. ಇದೆಲ್ಲ ಏನು ಅಂತ ನಿಮ್ಗೆ ಈ ಸೆಟಪ್ ನ ತೋರಿಸಿದಾಗ ಗೊತ್ತಾಗುತ್ತೆ. ಸೊ ಅವೆರಡರ ಮಧ್ಯೆ ಒಂದು ಫ್ರಾಕ್ಷನೇಟಿಂಗ್ ಕಾಲಮ್ ಅನ್ನ ಇಟ್ಟಿರ್ತೀವಿ. ಏನಿದು ಫ್ರಾಕ್ಷನೇಟಿಂಗ್ ಕಾಲಮ್ ಅಂದ್ರೆ? ಇಟ್ಸ್ ಎ ಕಾಲಮ್. ಓಕೆ, ಇಟ್ಸ್ ಎ ಕಾಲಮ್ in which there will be beads. Fractionating column will have beads present in them. Glass beads ಅನ್ನ ಇಟ್ಟಿರ್ತಾರೆ. Have beads which provide surface area for vapors to cool. ಬೀಡ್ಸ್, ಜಾಸ್ತಿ ಬೀಡ್ಸ್ ಹಾಕಿದಾಗ ಜಾಸ್ತಿ ಜಾಗ ಸಿಗತ್ತೆ ವೇಪರ್ಸ್ಗೆ ಕೂಲ್ ಡೌನ್ ಆಗ್ಲಿಕ್ಕೆ. ಸೊ ಫ್ರಾಕ್ಷನೇಟಿಂಗ್ ಕಾಲಮ್ ಅಲ್ಲಿ ಬೀಡ್ಸ್ ಅನ್ನ ಹಾಕಿಟ್ಟಿರ್ತಾರೆ. ಸೊ ಈಗ ವಿಡಿಯೋ ನೋಡ್ಕೊ ಬರೋಣ, ಡಿಸ್ಟಿಲೇಷನ್ ಹೇಗಾಗುತ್ತೆ ಅಂತ. ಲೆಟ್ಸ್ ವಾಚ್ ಅಂಡ್ ಕಮ್. So here we have simple distillation technique, again by Amrita Vishwa Vidyapeetham.
Simple distillation. Simple distillation is a method used for the separation of components of a mixture containing two miscible liquids that boil without decomposition and have sufficient difference in their boiling points. The distillation process involves heating a liquid to its boiling point and transferring the vapors into the cold portion of the apparatus, then condensing the vapors and collecting the condensed liquid in a container. Materials required: porcelain chips, mixture of acetone and water, 250 ml and 100 ml RB flasks, heating mantle,
RB ಫ್ಲಾಸ್ಕ್ ಅಂದ್ರೆ ಇದನ್ನ RB ಫ್ಲಾಸ್ಕ್ ಅಂತ ಹೇಳ್ತಾರೆ, ರೌಂಡ್ ಬಾಟಮ್ ಫ್ಲಾಸ್ಕ್.
Heating mantle, vacuum adapter, distilling head, thermometer adapter, water condenser, and stand with lamp. Procedure. Take a mixture of acetone and distilled water and pour it into a 250 ml RB flask.
Round bottom
Clamp
flask.
the RB flask to a stand and place it in a heating mantle. Take some.
ಇಲ್ಲಿ ಫ್ಲಾಸ್ಕ್ ಇದೆಯಲ್ಲ, ಇದನ್ನ ಡಿಸ್ಟಿಲೇಷನ್ ಫ್ಲಾಸ್ಕ್ ಅಂತಾನು ಹೇಳ್ತಾರೆ. ರೌಂಡ್ ಬಾಟಮ್ ಫ್ಲಾಸ್ಕ್ ನ ಡಿಸ್ಟಿಲೇಷನ್ ಫ್ಲಾಸ್ಕ್ ಅಂತಾನು ಕರೀತಾರೆ.
In a heating mantle. Take some porcelain chips and put them into the RB flask. Connect a distilling head to the RB flask and a thermometer adapter with thermometer to the distilling head. Connect a water condenser to the outlet of the distilling head and a vacuum adapter to the water condenser. Now, connect a 100 ml RB flask or receiver flask to the vacuum adapter. Place the RB flask into a beaker containing water. Then, connect a rubber tube between the tap and the inlet of the condenser to allow cold water to enter.
ಇದು ಕಂಡೆನ್ಸರ್. ಈ ಕಂಡೆನ್ಸರ್ ಅಲ್ಲಿ ಏನ್ ಮಾಡ್ತಾರೆ, ಕೋಲ್ಡ್ ವಾಟರ್ ಸಪ್ಲೈ ಮಾಡ್ತಾ ಇರ್ತಾರೆ. ಕೋಲ್ಡ್ ವಾಟರ್ ಸಪ್ಲೈ ಮಾಡಿದಾಗ ಬರ್ತಾ ಇರುವಂತ ವೇಪರ್ ನ ಕೂಲ್ ಡೌನ್ ಮಾಡೋದಕ್ಕೆ ಹೆಲ್ಪ್ ಮಾಡುತ್ತೆ.
Cold water to enter. Similarly, connect another rubber tube to the outlet of the condenser to pour the hot water from the condenser to the sink. Open the tap so that water flows through the tube and fills the condenser and then comes out through the outlet. Set the temperature of the heating mantle and heat the mixture to boil. At 56 degrees Celsius, acetone vaporizes and the vapors pass through the condenser and condensation occurs. The acetone is collected in the receiver flask in the liquid form and water is left behind in the distillation flask. Acetone boils at 56 degrees Celsius and water boils.
Please make note this, children. Acetone the boiling point to 56 degrees Celsius. Whereas water ಬಂದ್ಬಿಟ್ಟು 100 degrees Celsius. So difference ಬಂದ್ಬಿಟ್ಟು it's more than 25 Kelvin ಅಲ್ವಾ? ಅದಕ್ಕೋಸ್ಕರ we use simple distillation technique.
Boils at 100 degrees Celsius. Therefore, the miscible mixture of acetone and distilled water can be separated only by simple distillation. Since the acetone and water mixture forms an azeotrope, the procedure needs to be repeated to obtain the components in the pure state.
So hope you got to know how distillation happens, simple distillation. Okay, so let's see if fractional distillation is given. Yeah. Here we have fractional distillation technique.
Fractional distillation. Fractional distillation is used for the separation of a mixture of two or more miscible liquids for which the difference in boiling points is less than 25 Kelvin. The apparatus for fractional distillation is similar.
ಇಲ್ಲೂ ಸೇಮ್ ಇದೆ ಮಕ್ಕಳೇ, ಎರಡು ಅಪಾರ್ಟಸ್ ಸೇಮ್ ಇದೆ, ಇಲ್ಲಿ ಮಾತ್ರ ಡಿಫ್ರೆನ್ಸ್ ಕಾಣಿಸ್ತಾ ಇದೆಯಾ? Fractionating column is different, other setup is same
to that of simple distillation, except that a fractionating column is fitted in between the distilling head and the RB flask. Materials required. Mixture of ethanol and water. 250 ml and 100 ml RB flasks. Stand with lamp. Fractionating column. Distilling head. Porcelain chips. Thermometer adapter. Water condenser. Vacuum adapter. And heating mantle. Procedure. Take a mixture of ethanol and water and pour it into a 250 ml RB flask. Take some porcelain chips and put it into the mixture. Now, connect the fractionating column to the RB flask and clamp it. Connect a distilling head to the fractionating column and a thermometer adapter containing thermometer to the distilling head. Connect a water condenser to the outlet of the distilling head and clamp it. Now, connect a vacuum adapter to the water condenser and a 100 ml RB flask to the vacuum adapter. Clamp the RB flask and place it in a beaker containing water. Now, connect a rubber tube between the inlet of the condenser and the tap to allow the cold water to enter. Connect another rubber tube to the outlet of the condenser to pour the hot water from the condenser to the sink. Open the tap so that water flows through the tube and fills the condenser and then comes out through the outlet. Set the temperature of the heating mantle and heat the contents of the RB flask. At 78 degrees Celsius, ethanol vaporizes and the vapors rise through the fractionating column and pass through the
alcohol boiling point to 78 degrees Celsius. Water 100, so less than 25 Kelvin.
Condenser and condensation takes place and ethanol gets collected in the receiver flask in the liquid form and water is left behind in the distillation flask. Therefore, the separation of two or more miscible liquids for which the difference in boiling point is less than 25 Kelvin and can be done only by fractional distillation. Since ethanol and water forms an azeotrope, the distillation has to be repeated to obtain the pure component.
So, dear children, we have discussed about lot many techniques, right? To separate the mixture, we have started with the evaporation, centrifugation, separation funnel, separating funnel. Then we had discussed about, today we had discussed about chromatography, sublimation and distillation. I'll come back again with continued discussion of the chapter. Keep watching my videos, keep supporting me by liking my videos and subscribe my channel to get to know about more videos that I'll be uploading sooner. Thank you.